Hello and welcome to 7.7 Pied. So we are having some students plan several activities to celebrate Pi Day at their school, 3.14, March 14th. In addition to the pie eating contests and the pieing their favorite teachers, the math club plans to make money by selling slices of pie during lunch hour. Each member of the club has contributed a couple of homemade pies for the sale. Unfortunately, the members chose a variety of sizes and shapes of pans to make their pies in. Some students used 9-inch round pans for their pies, others used 8-inch round pans. A few used 8-inch square pans, and one student even used a 9 by 13-inch cake pan for his pie. Now, the club members have the dilemma of how to slice the pies so that each slice is about the same amount, since they plan to charge the same amount for each slice of pie, regardless of the pan it came from. After much debate, the club members have decided to slice the 8-inch round pie into 5 equal slices, or sectors, as the math geeks like to call them. The 9-inch round pies into 6 equal slices, and the 8 by 8-inch pies into 2 by 4 rectangles, and the 9 by 13-inch pie into 3 by 3 1/4-inch rectangles. Although the pieces look like they're all about the same size, some students think there might be a price advantage in buying one type of slice over another. So, which slice of pie is the largest and which is the smallest? And how did you decide? Well, in order to do this, we need to find each of the areas of the pie, right? So that's how we'll decide, is we'll find each area. And in order to do that, we need to find the area of the entire circles. It's interesting. The rectangular slices, we'll be able to find their areas just by multiplying base times the height, the base times the height, but the circular traditional pie slices, we won't be able to do that. But what we can do is we can figure out the area of the total round pie and then divide that into 5 equal slices, or into 6 equal slices, 6 equal pieces, respectively, for the 8 and 9-inch pies. So let's go ahead and find the areas of each of those. So here, let me get my pen out. First thing I'm going to start with is the 8-inch pie, which it's 8 inches across, but it's going to only be 4 inches as a radius, okay? So the area of this one is going to be pi times, get it, 4 squared, okay? So I'm going to have 16 pi. Now, we've talked about that we could just leave it like 16 pi, but since we're going to be comparing this with other pie slices, we're going to want to put it into actual square inch measurements. So we're going to actually multiply pi in. But before we do that, we also know that this pie is sliced into 5 equal slices. So this is the area of the entire pie, but we need to find out the area of one of those slices. So we're going to divide that by 5. So I'm going to go ahead and plug this into my calculator. Okay, so I'll have 16 times pi equals, and then divide that by 5. So this slice of pie will be about 10.05 inches. So let's go ahead and write that down, 10.05, and this is inches squared as well. All right, now we need to just continue on doing this for the next couple of pies. So we've got the 9-inch pie next, whose radius is 4.5 inches, okay? So we're going to do the area is equal to 4.5 squared, pi times 4.5 squared, which I don't know exactly what that is, but I do know that I'm going to divide it into 6 equal slices, so I'm actually just going to go ahead and plug that right in there already, okay? So now I can use my calculator. I'll go 4.5 squared. Whoa, I missed the point. 4.5 squared times pi, and divide that by 6 this time. So that's equal to 10.60 inches squared. So we've already found that this 9-inch pie is a slightly better deal, even though the pieces will probably look a little thinner. So now let's see the 8 by 8 inch, which is 2 by 4 rectangles. So 2 and 4, which the area there is just equal to 8 inches squared. Wow, that's not a great advantage. And then our 3 by 3 and a quarter inch rectangles, almost squares. Oops. So let's go ahead and multiply those together. 3 times 3.25, that's 9.75 inches squared. Okay, so there are all 4 of our pies represented now. So which piece is the largest? Well, it looks like that 9-inch pie is the largest. And which piece is the smallest? It looks like, based off our calculations, that 8 inches squared, or the 8 by 8 inch pie, is going to be the smallest. So, unfortunately, not everyone in the math club is good at eyeballing equal size sectors when cutting the round pies. Therefore, one of the students is assigned to be in charge of quality control. He's given a protractor and is told to reject any slices of pie that are more or less than 4 degrees from the exact angle measurement, okay? So when we slice this, let's say it's this 8-inch pie, when we slice it into 5 pieces, we know that we have 360 degrees total that we're dealing with, but we need to slice it into 5 pieces, so each piece should be 1/5 of 360 degrees. So each piece should be 72 degrees approximately. Now, we're saying that this quality controller, he gets 4 degrees of plus or minus. So every slice of pie needs to be within 72 degrees plus or minus 4 degrees. So that gives us a range of 68 degrees to 76 degrees, which actually, when you think about it, is a pretty big range of degrees, right? That's a pretty big range of margin, because it could be more than 4 degrees or less than 4 degrees. So someone might get a pie that's 76 degrees with that cut, while someone else might get a pie that's 68. So the 76 degree pie will be substantially more pie than the 68 degree pie. Okay, so let's look at what this has, or what this entails for us on the next page. Using this criteria, what's the smallest and largest amount of pie you might get in a slice of a pie taken from the 8-inch pan? Okay, so we had discussed, okay, well, if you cut it into 5 equal slices, that's all well and good. You get 10.05 inches, square inches per slice, but that's assuming that we get every slice correct. So if we get a slice that's 72 inches all the way around, if we get 5 slices like that, excellent. However, what might happen if we get the smallest pie, the smallest slice of pie that's acceptable, right? So that smallest slice, as we just looked at, if this whole thing, if each slice should be 72 degrees, but we have plus or minus 4 degrees, that means the smallest piece of pie could be 68 degrees, and the largest piece of pie could be 76 degrees, okay? But now, how do we deal with that when we're talking about the areas of sectors, right? Because now I'm talking about a sector with 68 degrees. Well, really what we were doing when we divided by the entire pie by 5 pieces is we were actually just creating a fraction, okay? If we go 372 divided by 360, that will actually just give us 1/5 when we divide that out, okay? So really all we were doing was multiplying the whole area by 1/5, okay? Or dividing by 5. That's what we did, right? So we're going to do the same fractional technique to take the entire area of the pie, which we determined in this pie was 16 pi inches squared, and we're going to multiply it by what fraction of the pie we're working with using that 68 degrees. So we're working with 68 degrees of 360. Okay, so that's what fraction of the pie we're now looking at. It's just kind of another way to say what we did here, but now we're using a degree measure that doesn't necessarily go super easily into 360 degrees. So what I'm going to do is I'm going to say, okay, I'm multiplying 16 times pi times 68 degrees, and then divided by 360 degrees. So I've included that fraction there. So that slice of pie is actually only 9.49 inches squared. Okay. which is interesting. I mean, that's almost, if we look back at our other page, that's almost, or that it's more than a whole ½ inch squared of pi less that we're getting, okay? So we're going to do the same thing and say, okay, what's the area of my pi? Well, it's 16 pi inches squared times what fraction of the circle I'm working with, what fraction of the pi I'm working with, which is 76 over 360. Here's my what fraction. So it's total area times what fraction. Now I'm going to plug those values in again. And I get 16 times pi equals times 76 divided by 360, that fraction, and that's 10.61 inches squared. So this value right here, well, that's just over 0.5 of an inch squared less than the perfect 72-degree cut. What's actually happening is this person's getting more than a full inch squared less than someone who gets a 72-degree cut, right? And they're paying the same price. So that's kind of an interesting thing. You want to get a slice that was mistakenly cut larger much more than you want to get a slice that was mistakenly cut smaller, because the impact could be a difference of over a full inch squared, okay? So now we're going to use this criteria to say what's the smallest and largest amount of pie you might see in a slice of pie taken from the 9-inch pan, okay? And when we look back at the 9-inch pan, the total area of the 9-inch pan was pi times 4.5 squared divided by 6. So now, let's see, pi times 4.5 inches squared. So that's the total area, this is right here, of the entire pie, okay? So I'm actually going to just go ahead and write that down for us so that we know exactly what we're working with. 4.5 squared times pi equals 63.62 inches squared, okay? Because we're going to need to use this information then to figure out the sectors, right? Now, if we want to look at what the area is of one of these slices, or what the degree measure is of one of the slices, so we now are separating this pie into 6 pieces, right? So we're dividing it by 6, which gives us 60-degree slices, okay? Now remember, we said that our margin of error, the quality controller said our margin of error could be as much or as little as 4 degrees, okay? So plus or minus 4 degrees, whoops. So let's go ahead and calculate, just like we did above, with minus 4 degrees and with plus 4 degrees, okay? So we'll be using that as our what fraction times the total area. So this time, we'll say pi times 4.5 inches squared times the fraction, what fraction of the circle we're working with, what fraction of the pi we're working with, which is 56 degrees over 360. Okay, so I'll go ahead and plug that in. 4.5 squared times pi, which is equal to that, times the fraction of the circle that we're working with. So 56 divided by 360. So that gives us 9.90 inches squared. So again, still more than the least amount up here, but not even as much as if we get a perfect 72-degree cut of our 8-inch pie. So that would actually minimize our amount of pie. Now how about let's do that with the 64 inches instead. The improper cut on the upside. So it'll be, times 4.5 inches squared times what fraction of the circle we're working with, which is 64 over 360. So let's go ahead and plug that in. 4.5 squared times pi, and then multiply it by 64, the fraction of what we're working with, and divide it by 360, and we get 11.31 inches squared. So this mistake has made even bigger of a difference, right? It's 1.41 inches of a difference, inches squared, where even above, it wasn't quite that drastic in the 8-inch pie, but we're getting a huge, much bigger slice of pie here. So if you bought this slice of pie and then compared it with this slice of pie, I mean, you're getting an enormous difference, not even to mention the 2 by 4 inch pie or the 3 by 3 1/4 inch pie, slice of pie, right? We're getting a lot more pie here for our money. So the student in charge of quality control finds that it's too difficult to measure the angle of a sector of a pie in degrees and suggests they cut a piece of string that could be used to measure the outer edge of the pie to let the servers know where to make the next cut. So that's kind of a clever idea. Rather than looking at the central angle, we're going to look at the arc measure. Okay, so what we need to know then is how long should the string be to measure the arc of a slice of pie for the 8-inch round pies, okay? So we need to figure out, okay, well, what portion of the circumference should I actually be cutting? How should that string be? And so what we're going to look at is what is the circumference? Because previously we've been looking at area of the pies, but now we're going to be dealing with the circumference because we're dealing with this distance to this distance, where the central angle is 72 degrees still, okay? So it's actually very similar to calculating the area of a sector, but instead of calculating area, we'll be calculating the circumference. So for this 8-inch pie, we have a diameter of 8 inches, and we all know that the circumference of a circle is pi times the diameter, or 2 times the radius times pi, right? So we'll go 8 inches times pi, all right? So that's our full circumference right there. But we need the circumference of the portion of the circle that we're working with, or the portion of the pie that we're working with. So the way that I like to say this again is, what fraction of the pie are we working with? Well, what fraction is times 72 over 360, right? We're working with 72 360ths of that pie. So I get to go ahead and multiply that circumference, 8 times pi, by the fraction of the circle we're working with, 72 divided by 360, and I get 5.03 inches, okay? And not inches squared here, right? This is just 5.03 inches of string. So our string that we'll use to wrap around the pie to see how long our cut should be will be 5.03 inches. So now what about the measurement for the slice of the pie for a 9-inch round pie? Well, we're going to do something very similar, okay, where we have 9 inches all the way across. That's the diameter. So the circumference is 9 times pi, okay, and then we're going to multiply it by the fraction of the circle we're working with. Remember, we're cutting this one in sixths. So what we'll do is we'll multiply it by a factor of 60 over 360. That's what fraction of the circle we're working with. So let's go ahead and do that. We have 9 times pi equals times 60 divided by 360. That length is 4.71 inches. Okay, so the string that we'll use for this smaller pie, or for this larger pie, is actually going to be 4.71 inches, which, when you think about it, that slice is thinner than the slice above of the 8-inch pie. But notice that the area is greater because of the radius and because of the increase in the diameter, right? So that is a larger piece. Even though the circumference, the portion of the crust, is smaller, it's actually going to contain more pie. But that might even be something to consider. Are you a crust person? You might want to go ahead and get the slice of pie that has 5.03 inches of crust rather than 4.71 inches of crust because you dig the crust. Who knows? So let's go on to the next page. Wendell really likes pie and has offered to pay double the price for a slice of pie that is guaranteed to contain at least 15 inches squared of pie, which to me, that's just kind of interesting. I would sooner just buy 2 slices of pie and you get almost 18 inches squared. But, oh well, Wendell just wants double, or just wants 15 inches squared. He doesn't want a full double slice. So we need to figure out, okay, what's the degree measure of the smallest sector of the 8-inch round pie that will satisfy Wendell's cravings? So again, we have our 8-inch pie here with the radius of 4, and we need to get that to equal 15 inches squared, okay? So the area is equal to 15 inches squared. So now we need to say, okay, well, I know that the area is actually pi times the radius squared times the fraction of the circle that I'm working with, right? But I don't know how big that central angle is. So this is how I'm going to write an equation. Okay, so I've got the area of the total circle, the area of the slice that I want, and then I'm going to figure out, okay, what's the fraction of the slice that I want? Okay, so what I'm going to do is I know what r squared is, so I'm going to plug that in. And I'm going to do some dividing, okay? So I'll divide by pi r squared on both sides, so pi r squared. And then I'm going to get rid of this 360 in the denominator by multiplying both sides by 360. So everything's canceled off on the left side except for x. And I'm multiplying by 360. So now I have x equals 15 inches squared times 360 degrees divided by pi times, and remember my radius is 4, so radius squared is 16. Okay, so this is actually how I'm going to figure out what that central degree measure is. Okay, so I should also say this is inches squared, right? So inches squared will cancel off, and I'll be left with those degrees, which is really what I want. So let's plug that into my calculator. I have 15 times 360, and I'm going to divide that by 16 and divide that by pi. So I get a degree measure of 107.43 degrees. So this slice of pie needs to be 107.43 degrees, okay, in order to create a slice of pie large enough for 15 inches squared of pie. Now, if I'm looking at the string to measure the circumference, I can actually use this same value now. I don't have to worry about the area anymore because I've already solved the central angle. So I'm going to look at the circumference of the circle, which is 8 pi, and then I'm going to multiply it by the fraction of the circle that we're working with, 107.43 degrees divided by 360 degrees, right? And I'm going to just go ahead and plug that into my calculator. So 107.43 divided by 360, that's the fraction of the circle I'm working with. And I'm going to multiply that by 8 and by pi because that's the circumference of the entire circle. So the circumference of the string that I need is going to be 7.5 inches, okay? Almost exactly 7.5 inches. So even... this is going to be a more accurate measurement, too, than this 107.43. So what I would probably do is I'd just measure a string that distance, and then I'd cut it based off of that distance since it's a nice even or nice almost rounded number, 7.5 inches, versus this 107.43. That would be really hard to do with a protractor. So this might be the more beneficial route. So how about the degree measure of the smallest sector of the 9-inch round pie that will satisfy Wendell's cravings? So again, we need the area to equal 15 inches squared, right? But we don't know the fraction of the circle that we're working with. So we're going to set up the area of the whole circle. So pi times 4.5 inches squared. Times the fraction of the circle that we're working with, but we don't know what that fraction is yet, so that's what we're going to solve for, and that equals 15 inches squared. So now I can again do the same thing where I divide by pi and 4.5 squared, and then I will multiply by 360, and I'll do that all to both sides. Oops, 4.5 squared. There we go. So I'll plug that into my calculator now. So I've got 15 times 360 divided by 4.5 squared. And I'll divide it once more by pi. So the central angle that I need here is 84.88 degrees. All right, so x is equal to, oh, I should cancel those off. Let's see, what did I say? 84.88 degrees. Okay, But how long should the string be to measure the arc of this sector? Well, let's take the circumference and multiply it by this fraction of the circle that we're working with. So the circumference is 9 times pi times the fraction of the circle we're working with. And we'll go ahead and see how that goes in our calculation. So we've got 9 times pi times, let's see, what was it? 84.88. So times 84.88 and divided by 360 because that's the fraction of the circle we're working with. And that will be 6.67 degrees, or 6.67 inches, excuse me, which is 6 2/3 inches as well, not degrees, inches. Okay. So that would be the measure of the circumference that we would actually cut off. So a sector of the 9-inch pie, round pie, measures n degrees. What is its area and what is its arc length? So what they want us to do now is they want us to use the same process that we've been doing, but instead of using an actual degree measure, we're going to use a variable, which we've been doing up here, like with x, right? So we're going to say the area is equal to the area of the entire pie, which is 4.5 squared, the radius squared, times pi, times the fraction of the circle we're working with, which is just n degrees over 360 degrees, okay? So there we go, and you could even write it, if you wanted to, you could write it as 20.25 pi times n degrees over 360. That's just after having squared 4.5. And then the circumference. Let's talk about the circumference, or it's the arc length, rather. We're going to take the circumference of the entire circle, so 9 pi, and we're going to multiply it by the fraction of the circle that we're working with, n over 360 degrees. Okay? So that's actually just that right there. There you go. The area and the arc length. All right? So hopefully this gives you some clarity. The big key thing here, as I've been repeating over and over, is when we're looking at sectors or portions of the circumference, we're going to just multiply the whole circumference or the whole area by the fraction of the circle that we're working with. Okay, that's the big thing to key in on here. All right, enjoy your RSG.